Hi guys, I hope you guys are doing well. Okay, so last Monday I posted about the sum of finite geometric series. Okay, so provided by the Khan Academy. I noticed that a lot of you did a really good job on the Delta Math, and a lot of you signed up. So you're doing a great job. So if you have any question about the assignments, anything, so please contact me via email or via Hangout. All right. So before we start, I just want to give you like a short summary about what we learned last Monday. So the last Monday, the video, the assignment is about the sum of finite geometric series. In that case, we can use the formula. So the summation is a sub 1, which stands for the first term, 1 minus r to the n stands for the number of terms, over 1 minus r, as we know the r stands for the common ratio. So for example, we are given in sigma notation and starting at 1 to 7, 1 over 4 to the n. So I kind of like find out the a1 and the r. So we know this one is r to the n, so which means how it looks like 1 over 4 plus 1 over 4 to the second plus 1 over 4 to the third, right? So we know that the common ratio is a 1 common ratio is a 1 over 4. And at the same time, we need a first term. So first term is a 1 over 4. So a1 is a 1 over 4. The n stands for the number of terms. So think about it. N starting 1 to 7. So 1, 2, 3, 4, 5, 6, 7. So we know we have a 7 terms. So once you find out that, we can just plug in the formula. So summation is a1. 1 over 4 times 1 minus 1 over 4 to the 7, isn't it? Isn't it 1 minus 1 over 4? So let's simplify, which is a 1 over 4 times, but then the denominator, isn't it 3 over 4? So I want to multiply by the reciprocal, which is a 4/3, times 1 minus 1 over 4 to the 7th power. So in this case, you can cancel them out, which gives us 1/3 times 1 minus 1 over 4 to the 7th. In that case, you don't have to simplify. Now, so today we're going to talk about the sum of a finite geometric series. So in this case, the number of terms is a finite. So it could be up to 7th term, it could be up to 100th terms, it could be up to like a 20,000th terms. So which means a number of terms are finite. But in that case, we have an infinite geometric series. So in that case, we may use the formula A, which is the first term of the geometric series, over 1 minus r. R stands for the common ratio. So if you see the difference between these two, so we have a 7, which is the upper bound, right? So which is, we gotta find out the summation up to 7th term. So now instead of a number, we are given an infinity, which means this series keeps going on and on and on and on, right? So in that case, we need a first term. If you plug in a 1, the first term is a 1 over 4. And for common ratio, we know this one is a 1 over 4. Since we have a and r, we can just plug in the formula, which is a 1 over 4 over 1 minus 1 over 4. So which is a 1 over 4, isn't it, over 3 over 4? So fraction over fraction. So 1 over 4 times the reciprocal of denominator, which is a 4 over 3, cancel out. So we know this one is approaching to the 1/3. Now the next one is what we're going to do. So this one is kind of review. So the last time we kind of like practice how we can fill out the blank, right? So as you see here, we're given two examples, 6, 8, 10, 12, 14, 16, and 18, right? So first of all, we have to find out the pattern to figure this out. As you see here, 6, 8, it goes by plus 2, and then plus 2, and then so on. So we know this one looks like a 2n, okay? And starting at 1. Okay, but we know the 2n doesn't work. The reason why, because if you plug in a 1, it is a 2, not 6, right? But how we can make a 6? When you plug in a 1, we need 2 plus 4, right? So plus 4. Okay, so I want to check if you plug in a 1, 2 times 1, 2 plus 4, 6. Okay, now when you plug in a 2, 2 times 2, 4, 4 plus 4, which is 8. Let's try one more time. I want to plug in 3, so 2 times 3, 6 is 6 plus 4, which is 8, right? Now we need an upper bound. So how many terms? 1, 2, 3, 4, 5, 6, 7. So this one is a 7. All right. Now let's try the next one. The next one is a 8 plus 10 plus 12 plus 14 plus 16 plus 18 and 20, right? So we know each one goes by 2 again, right? So we have a 2n and n starting at 1, right? Okay, so and then if we plug in a 1, we have a 2, but we're going to make 8, right? So which is 8 and plus, isn't it 6, right? So let me plug in a 2. 2 times 2, 4. 4 plus 6, which is a 10. But how many terms? 1, 2, 3, 4, 5, 6, 7. So my upper bound is a 7.